Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving zeros of a quadratic function using the quadratic formula. Alright.
The quadratic formula for real numbers a, b, and c with a not equal to 0, the solution of a quadratic function ax squared plus bx squared plus c is equal to 0 is given by the formula x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now take note that the quadratic formula can solve all quadratic equations, including those that are not factorable. Here are the steps in solving quadratic functions using the quadratic formula. So first, we need to write the equation in standard form, wherein ax squared plus bx plus c is equal to 0. Then step 2, list down the numerical values of the coefficient a, b, and c. Now step 3 is to write the formula, then substitute the value of the coefficient a, b, and c, and then solve for the value of x. Now let's go on to our examples in solving quadratic functions using quadratic formula. Alright, okay, let's have an example. So for example, we're going to solve for the zeros of a quadratic function. A of x is equal to x squared plus 5x plus 4. So first is we need to get the numerical values of a, b, and c. So in this case, our a is equal to 1, our b is equal to 5, and our c is equal to 4. Then let's substitute this to our formula or our quadratic formula. So we have x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So let's substitute the values of a, b, and c to this formula. We will have negative 5 plus minus the square root of 5 squared minus 4 times 1 times 4 all over 2 times 1. Simplifying this, we will have negative 5 plus minus the square root of 25 minus 16 all over 2. 25 minus 16, we will have 9. We have x is equal to negative 5 plus minus the square root of 9 all over 2. Now, the square root of 9 is 3. Therefore, we will have x is equal to negative 5 plus minus 3 all over 2. Now, we can combine like terms, but take note we have two operations, plus and minus, because we get the positive and negative roots of our radical. So, we will have two possible answers. We have x is equal to negative 5 minus 3 all over 2, and x is equal to negative 5 plus 3 all over 2. Now, simplifying the one on the left, we will have x is equal to negative 8 over 2, and negative 8 over 2 is equal to negative 4. And now the other one, the one on the right, negative 5 plus 3 all over 2 is equal to negative 2 over 2. Simplifying that, we will have x is equal to negative 1. Now the zeros of our quadratic function is negative 4 and negative 1. Okay, let's have another example. Let's solve for the zeros of the quadratic function b of x is equal to negative 3x squared plus 9x minus 4. First thing that we need to do is to identify the values of a, b, and c from our quadratic function. So our a is equal to negative 3, our b is equal to 9, and our c is negative 4. Now, let's substitute these values of a, b, and c to our quadratic function. So our quadratic function is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So substituting the values of a, b, and c, we will have x is equal to negative 9 plus minus the square root of 9 squared minus 4 times negative 3 times negative 4 all over 2 times negative 3. Now, let's combine like terms. Let's simplify. We will have x is equal to negative 9 plus minus the square root of 33 all over negative 6. So, let's simplify if possible, since we have negative 9 and negative 6 in our numerator and denominator, and our operation for square root of 33 is positive and negative, we can cancel out the negative sign. We will have x is equal to 9 plus minus square root of 33 all over 6. And then from there, we will now have our two answers. So we have x is equal to 9 minus square root of 33 over 6. And we have x is equal to 9 plus square root of 33 all over 6. This will be the zeros of our quadratic function. So we have 9 minus square root of 33 all over 6 and 9 plus square root of 33 all over 6. And let's have another example in solving zeros of a quadratic function. C of x is equal to 5x squared minus 2x plus 7. So first thing that we need to do is to get the values of a, b, and c from our quadratic function. So we have a is equal to 5, b is equal to negative 2, and c is equal to 7. We will substitute this to our quadratic function. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now let's substitute. We will have negative 2 plus minus the square root of negative 2 squared minus 4 times 5 times 7 all over 2 times 5. Let's simplify. So we will have x is equal to 2 plus minus the square root of 4 minus 140 all over 10. Let's combine like terms. We will have x is equal to 2 plus minus the square root of negative 136 all over 10. Let's simplify the square root of negative 136. We will have x is equal to 2 plus minus 2i square root of 34 all over 10. Now, since we have a common factor that is 2, we can cancel out their common factor. Let's simplify by canceling 2 to our numerator and our denominator. We have two values of x. Let's separate the operation. We have x is equal to 1 minus I square root of 34 all over 5, and x is equal to 1 plus I square root of 34 all over 5. Now, the zeros of our quadratic functions are 1 minus I square root of 34 all over 5 and 1 plus I square root of 34 all over 5. Alright, and let's have our last example for today. So for example, we're going to solve for the zeros of a quadratic function. D of x is equal to 2x squared minus 3x minus 9. So first thing that we need to do is for us to identify the values of a, b, and c. So our value of a is 2. Our value of b is negative 3, and our value of c is negative 9. Now let's substitute the values of a, b, and c to our quadratic formula, which is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now substituting the values, we have x is equal to negative 3 plus minus the square root of negative 3 squared minus 4 times 2 times negative 9 all over 2 times 2. So let's simplify. We have 3 plus minus the square root of 9 plus 72 all over 4. Now combining like terms, we will have x is equal to 3 plus minus square root of 81 all over 4. Now, the square root of 81 is 9, so we will have x is equal to 3 plus minus 9 all over 4. Now, since we will combine like terms, we will have two operations for our numerator. The first one is x is equal to 3 minus 9 all over 4, and the other one is x is equal to 3 plus 9 all over 4. So let's simplify our first equation. We will have x is equal to negative 6 all over 4, and simplifying that, our x is equal to negative 3 over 2. While on the left equation, or let's combine like terms, we have x is equal to 12 over 4, and simplifying that, our x is equal to 3. So the zeros of our quadratic functions are negative 3 over 2 and 3. Alright.
Now that you already know how to solve zeros of a quadratic function using the quadratic formula, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!